In Module 3, the instructor will cover the chemical and physical differences between gasoline, ethanol, and ethanol-blended fuels. Just like gasoline, ethanol must be flammable in order to be used as a fuel. However, ethanol behaves differently than gasoline and more like a polar solvent.
The objective: upon completion of this module, participants will be able to describe the chemical and physical differences between gasoline, ethanol, and ethanol-blended fuels. We want you to be able to understand the chemistry of gasoline, ethanol, and ethanol-blended fuels, and we want to describe the characteristics of ethanol-blended fuels. In order to understand the nature of ethanol-blended fuels, responders will need to understand the characteristics of polar solvents and hydrocarbons, their differences, and how these types of products interact. Ethanol is classified as a polar solvent. A polar solvent is a compound such as alcohol, most acids, or ammonia with a separation of charge in the chemical bonds. These have an affinity for water and will readily go into solution. Under some conditions, ethanol-blended fuels will retain certain characteristics as a gasoline-type fuel, and under others it will exhibit polar solvent-type characteristics. Understanding these conditions will help responders mitigate the various incidents according to the conditions found. Hydrocarbon fuels, such as gasoline, diesel fuel, kerosene, jet fuel, etc., generally have similar characteristics whether they are flammable liquids or combustible liquids. In this program, we will specifically identify the characteristics of gasoline as they relate to ethanol and gasoline blends. Gasoline is a hydrocarbon produced from crude oil. It is immiscible with water and will not mix with water at any concentration. It has a flash point of approximately 45 degrees below zero Fahrenheit, varying with octane rating. Gasoline changes seasonally and is blended specifically for each region of the country. An important point to note is that even in winter weather, it will ignite. Gasoline has a vapor density between 3 and 4. Therefore, as with all products with a vapor density greater than 1, gasoline vapors will seek low levels or remain close to the ground level. Gasoline has a specific gravity of 0.72 to 0.76, which indicates it will float on top of water since it is immiscible or insoluble. Its auto-ignition temperature is greater than 530 degrees Fahrenheit. Gasoline varies in composition. It is a mixture of many hydrocarbons, typically with a boiling point between 100 degrees Fahrenheit and 400 degrees Fahrenheit. But some portions will boil at less than room temperature. Gasoline is not considered a poison, but does have harmful effects after long-term and high-level exposure that can lead to respiratory failure. Smoke from burning gasoline is black and has toxic components. The toxic components found in gasoline include benzene, toluene, xylene, heptane, hexane, etc. Gasoline's greatest hazard is its flammability, even though it has a fairly narrow flammable range. That flammable range is its LEL of 1.4% and UEL of 7.6%. Gasoline is produced from crude oil. Crude oil varies greatly in color and viscosity from oil well to oil well. Largely dependent upon the geographic region where the crude oil originated, crude oil is transported via pipeline, freighter, ship, barge, rail car, and tank truck to an oil refinery where it is processed into refined products like gasoline. An oil refinery uses engineering techniques such as fractional distillation and alkylation to produce gasoline. Similar to crude oil, gasoline is also transported via pipeline, freighter, ship, barge, rail car, and tank truck until it ultimately reaches retail fueling stations and consumers. Ethanol is a renewable fuel source that is produced by fermentation and distillation process of starch containing products like corn and sorghum in the United States. In Brazil, the primary feedstock for ethanol production is sugarcane. New feedstocks are being developed for ethanol products such as corn cobs, corn stover, which is the leftover products from corn when it's been harvested in the field, switchgrass, and other natural products that will be conducive to the fermentation distillation process. An ethanol biorefinery uses engineering techniques similar to gasoline production, such as distillation and dehydration, to produce fuel-grade ethanol. Ethanol for use in motor fuel blends will generally be denatured with between 2 and 5% gasoline or a similar hydrocarbon. Denaturant has minimal effect on the overall characteristics of ethanol, except for the flash point. The addition of the denaturant further depresses the flash point. This training program focuses on denatured fuel ethanol.
Ethanol production process. In dry milling, the entire corn kernel or other starchy grain is first ground into flour, which is referred to in the industry as meal. The meal is slurried with water to form a mash. Enzymes are added to the mash to convert the starch to a simple sugar. The mash is processed in a high-temperature cooker, then is cooled and transferred to fermenters where yeast is added and the conversion of sugar to ethanol and carbon dioxide, or CO2, begins. The fermentation process generally takes about 40 to 50 hours. After fermentation, the resulting beer is transferred to distillation columns. The ethanol is concentrated to 190 proof, or 95% ethanol, using conventional distillation, and then is dehydrated to approximately 200 proof, or 100% ethanol, in a molecular sieve system. The anhydrous ethanol is then blended with about 2 to 5% denaturant, such as natural gasoline, to render it undrinkable and thus not subject to beverage alcohol tax. It is then ready for shipment to gasoline terminals or retailers. Ethanol's co-products, such as the coarse grain and the syrup, are then dried together to produce dried distillers' grains with solubles, or DDGS, a high-quality, nutritious livestock feed. The carbon dioxide released during fermentation is captured and sold for use in carbonating soft drinks and beverages and the manufacture of dry ice.
Denatured fuel ethanol is a polar solvent that is water soluble. A polar solvent is a compound such as alcohol, most acids, or ammonia with a separation of charge in the chemical bonds. These have an affinity for water and will readily go into solution. Denatured fuel ethanol has a flash point of 5 degrees below 0 Fahrenheit and a vapor density of 1.5, which indicates that it is heavier than air. Consequently, ethanol vapors do not rise, similar to vapors from gasoline, which seek lower altitudes. Denatured fuel ethanol's specific gravity is 0.79, which indicates it is lighter than water, and it has an auto-ignition temperature of 709 degrees Fahrenheit and a boiling point between 165 and 175 degrees Fahrenheit. Like gasoline, denatured fuel ethanol's greatest hazard as a motor fuel component is its flammability. It has a wider flammable range than gasoline. Ethanol's LEL is 3% and its UEL is 19%. From the chart, there are some very similar properties of gasoline versus denatured fuel ethanol. Importantly, there are also very different inherent properties. It is important to note that gasoline is a complex mixture of over 500 compounds that may have between 5 and 12 carbon atoms. Denatured fuel ethanol is a 2-carbon alcohol, also referred to as ethyl alcohol, that has 2 to 5% of a denaturant added to render the product undrinkable. Both gasoline and ethanol are very flammable products. Gasoline has a lower flash point of 45 degrees below zero Fahrenheit compared to 5 degrees below zero for ethanol. The densities of gasoline and denatured fuel ethanol are similar. Both fuels are lighter than water, which has a density of 1. Gasoline has a very broad boiling point range, which indicates components will boil off over a broad temperature range. Ethanol, on the other hand, has a very narrow boiling point range. Ethanol has a lower vapor pressure than gasoline, 3 psi versus 8 to 15 psi for gasoline. Note the differences in the flammability ranges for these two products. It is also important to understand the great difference between the water solubility of ethanol versus gasoline. 100% ethanol, undenatured, is also known as neat ethanol. In its neat form, there's going to be very little smoke produced, and the flame is going to be very hard to detect. In its denatured form, the flame will begin to be more orange, and there will be a production of smoke. Depending upon how much gasoline I add to the ethanol, the flame will become more noticeable and the smoke will become more noticeable. Responders many times were taught to add water to the ethanol, and you can get it to the point where it will no longer burn. But the addition of water to ethanol actually has to be at a 5-to-1 ratio before the water will cause the ethanol not to burn. So for every gallon of ethanol, I need 5 gallons of water added before I can get to the ethanol to the point where it is non-flammable. Reminder, as a first responder, use the thermal imaging camera. Your TIC camera should be one of the first instruments off the truck in a hazmat incident to verify whether or not a product is on fire. If the ethanol is not showing any obvious signs of fire, the thermal imaging camera may be there to show you that yes, it is still burning. Blending ethanol with gasoline has multiple effects. The higher the concentration of ethanol, the more the fuel has polar solvent type characteristics with corresponding effects on conducting fire suppression operations. Water introduction to ethanol and gasoline fuel blends has a dramatic effect. Without water, ethanol and gasoline blends are homogeneous. Ethanol has an affinity for water. For instance, it is not necessary to add any gas line antifreeze to a gasoline ethanol blend, since the ethanol will absorb trace amounts of water and pull it through the fuel system of the vehicle. In the case of using water to extinguish a fire during response efforts, the water can pull the ethanol out of the blend, resulting in a separate layer comprised of water, ethanol, and some hydrocarbon content. The gasoline will remain in the top layer. This is the result of the ethanol having more polar character than non-polar character.
Phase separation can occur in fuel storage systems where water is present, or get into the system, which is a rare occurrence.
Blending ethanol and gasoline will alter the physical and chemical characteristics of the original fuel. Visual difference in smoke, visual difference in the amount of fire that responders see will occur. So the higher the concentration of ethanol, the less visible black smoke, the less visible the orange flame.
The video, Responding to Ethanol-Related Incidents, shows that the most effective route for keeping an ethanol fire under control is the use of alcohol-resistant foam, more commonly known as ARAFFF. As ethanol is a polar solvent, this foam contains a special polymer which creates a barrier between the foam and fuel, which forms a cohesive blanket to extinguish the fire. This foam blanket not only helps manage the fire, it will also keep other spills from catching, prevents any reignition, and can provide post-fire security. Because the AR foam is universally suitable for use on both ethanol and non-ethanol blended fires, the best practice is for emergency responders to keep an AR foam readily available for these incidents. Another noticeable difference of ethanol-blended fuels under fire conditions is that when foam or water has been flowed on the burning product, the gasoline will tend to burn off first, eventually leaving the less volatile ethanol water solution, which may have reduced visible flame or smoke.
In summary, ethanol is a polar solvent that is miscible with water and is flammable. Knowing ethanol will be the last fuel to burn and that it may burn with little visible smoke or flame is important in determining an approach to take in dealing with ethanol-involved incidents. The most effective route for keeping an ethanol fire under control is the use of alcohol-resistant foam, more commonly known as AR-AFFF. Because the AR foam is universally suitable for use on both ethanol and non-ethanol blended fuel fires, the best practice for responders is to keep an AR foam readily available for these incidents.